Hi everyone, I hope you are all fine. Let's start solving exercise 4, page 191 from the book. Observe the given figures and answer the following questions. So part 1, we have AB equals to AC and DE is parallel to BC. Let me put the parallel sign and let's start with the first given. When I say that AB equals to AC in the triangle ABC, this means that triangle ABC is an isosceles triangle. Now, we know that the isosceles triangle has two main properties. The first property is that the sides are equal, and this is given, which is AB equals to AC. And the second important property is that the base angles should be equal. Another given is that DE is parallel to BC, and we know that through parallel lines we can find corresponding angles and alternate interior angles, as we mentioned in the lesson before. So I can extend the lines here because the parallel lines are lines, so we can extend them as much as we can. We need to prove that the triangle ADE is an isosceles triangle. Now again, for triangle ADE, I have two ways to prove that this is an isosceles triangle. I either prove that AD is equal to AE, it means I prove that the two sides are equal, or I can prove that by showing that the two angles at the base, which are D and E, are equal. Now, since there is no given that helps me to prove that AD is equal to AE, then I need to think about the angles. And since we have parallel lines and our lesson is about angles and parallel lines, so I can think of corresponding angles or alternate interior angles. Let me show you the corresponding angles in the figure, because here actually we have the F shape, and above the line I have a pair of corresponding angles. So I can say that angle D is equal to angle B. So angle D is equal to angle B, and they are corresponding angles between the two parallel lines. On the other side, I can also take the upside down F. So this is the upside down F, and this would help me to say that angle E is equal to angle C, and these are also corresponding angles. So E is equal to C, and these are corresponding angles. Now let me compare. I want to reach a point that helps me say that D and E, the two angles, are equal. Let me compare as we used to do previously in the previous chapters in geometry. Angle D equals to B, angle E equals to C, but what about B and C? But angles B and C are equal because these are base angles of isosceles triangle, because in the beginning of this video I have just mentioned that ABC is an isosceles triangle and angles B and C are equal. So by comparison I can say that angles D and E are equal. Now since angles D and E are equal, then I can say now that triangle ADE is an isosceles triangle of main vertex A. So let's start writing the proof. I need to prove first that triangle ABC is an isosceles triangle. Okay, so we start, since AB equals to AC given, then triangle ABC is isosceles of main vertex A. Now, what do I mean by main vertex A? If you look at the triangle at ABC, this is the main vertex, and these are the equal sides. AB and AC are the equal sides. So that's why we say this is the main vertex, just to see where are the equal sides and where are the base angles. Okay, that's why we say of main vertex A. Now let's start our proof. Angle ADE, because I want to prove that triangle ADE is an isosceles triangle, and again I need to prove that by the angles. So angle ADE equals to angle ABC, and the reason is corresponding angles between two parallel lines. Now I either put the sign or I write the word parallel. Both are acceptable. What are these lines? DE and BC. And for the upside down F, I can take angle AED with ACB. So I say AED equals to angle ACB, and the same reason, corresponding angles between two parallel lines DE and BC. Notice that in this drawing we took different secants. The first secant for the first F was this secant, and for the upside down F I took another secant, which is this line. Now we reach the comparison part, but ABC equals to ACB, and the reason is that they are base angles of isosceles triangle ABC. We proved that ABC is an isosceles triangle in the beginning, so these are the base angles, and it's a property that base angles of isosceles triangles are always equal. Then ADE equals to AEC, or AED, ADE equals to AED by comparison. Now, since these two angles D and E, since these two angles are equal now, so triangle ADE is isosceles of main vertex A. So therefore triangle ADE is isosceles of main vertex A. So we're done with part 1. Let's move now to part 2. We have AX is parallel to BC. So let's put the two codes that shows that the two lines are parallel, and we need to find BAC. We need to find the missing angle BAC. Now let's look very well, guys. I have two parallel lines that are cut by a secant. They make the letter Z. look at Z. Now why do I need Z? Because Z will help me find C. If I find C, then I will have one missing angle in the triangle ABC, which is angle A, and this will be easy to be calculated, because in any triangle ABC, I can have two given angles and then one missing angle. Okay, but I can't have two missing angles in the triangle. It's going to be difficult to be solved. That's why the first method here, or the first point I can get it, or the first angle, is to find angle C. So angle C is alternate interior angle with angle A, then C is 31 degrees. Now I need to find angle A, and I know that the sum of angles in a triangle is 180 degrees, so it's so easy to get angle A now. So let's start by calculating angle C. So we say ACB is equal to XAC equals to 31 degrees, and the reason is alternate interior angles between two parallel lines AX and BC. Now I can find the missing angle in triangle ABC, so let me specify in which triangle I'm working. In triangle ABC, angle B, which is ABC. Now I prefer to write the way of calculation as follows: ABC plus ACB plus BAC equals to 180 degrees, and don't forget the reason: sum of angles in a triangle. That's why I put 180 degrees. Now this is the missing angle, which is BAC, so I can say that BAC equals to 180 minus. Now some students might start with this part. It's fine, you can, or with this step, you can just skip the first step. 180 minus ABC plus ACB. So that's also acceptable, but here you need to put the reason: sum of angles in a triangle, if you start with step 2. So this is 180 minus 67 plus 31, which is 180 minus 98, and the final answer is 82. So that implies angle BAC equals to 82 degrees. So what I did here is I used the property of two parallel lines that are crossed or cut by a secant in order to get the alternate interior angle, and after that I get the missing angle A. Let's move to the last part, which is part 3. AD is the bisector of angle BAC, and this is very clear from these two codes. These codes show that the two angles are equal because of the bisector, because the angle bisector cuts the angle into two equal and adjacent angles. And we have AD is parallel to CE. So let me put the parallel sign. Now we need to prove that triangle ACE is an isosceles triangle. Now again, there are two ways to prove that a triangle is isosceles. The first way is to prove that it has two equal sides, and then it's going to be isosceles. And the second way is to prove that it has base angles, two equal base angles. Now, since there is no given that helps me to prove that the two sides AE and AC are equal, then I need to forget about the sides and think about the angles. And because our lesson is about angles, and because we have given two parallel lines, then let me search for pairs of corresponding angles and alternate interior angles. Now, the starting point of this part is the bisector. The bisector AD cuts BAC into two equal parts. I'm gonna call this angle 1 and this angle 2, as we used to do before, in order to compare angles. And then I will say angle 1, automatically you will see where is angle 1 instead of saying DAC. Let me look at the two parallel lines and let me focus at these angles. Okay, now, and I know that you have too many secants, so you have to take only two parallel lines and one secant. I will take these two parallel lines and the secant. AC is going to be the secant. And look at this shape. What's this shape? This is a Z. This means that the angles at the corner of Z are equal. So angle 1 and angle C are equal. I'm gonna put here 1. You see, guys, the Z? So 1 and 1 are equal, and the reason is that we have alternate interior angles between two parallel lines AD and CE. Now I want to move to angle E because I want to check this angle, and I just need to find a way to prove that angles C and E are equal. Let me take the two parallel lines again here with a different color now and the secant. I will take line EB as the secant. So you just need to focus on the blue lines. Okay, so let me compare below the line. Below the line I have two angles that are corresponding angles. You see the two parallel lines, you see the secant, below the line, below the line. So this means that angle 2 and angle 2, which is angle E, are equal. So look, guys, 1 and 1 are equal, alternate interior angles. 2 and 2 are equal, corresponding angles. Now, what about these 1 and 2? These are equal because of the bisector. Then by comparison, these two will be equal, and then because C and E are equal, then triangle ACE is going to be an isosceles triangle. So I will start writing the proof, and after that you can check again what I wrote so that you understand the exercise more and more. So let me start by writing that angle DAC equals to angle ACE, and the reason is alternate interior angles between two parallel lines AD and CE. Notice guys that if we don't have parallel lines, we can never solve using corresponding and alternate interior angles. So this is the first part. The second part, angle DAB equals to angle AEC, and the reason is that we have corresponding angles between two parallel lines AD and CE. Now let me compare. But DAC equals to DAB because of the bisector. But DAC equals to DAB, and the reason is that AD is the bisector of angle BAC. Now you either write this, or you can write AD is the bisector given, or you can write the effect of the bisector. All are acceptable. Then ACE and AEC are equal by comparison. So then ACE equals to AEC by comparison. Now since these two angles are equal, therefore triangle ACE is isosceles of main vertex A. Now why with main vertex A? Look at the figure guys. Because these are the base angles, so A will be the vertex. So this is everything. I hope you understood these exercises, and thank you so much for listening.